I don't know
No,
what.
no. No, you then, quickly just remove your background.
Okay.
So, and make your, background blur.
Blur.
Yes.
Okay. Now,
No,
so
no.
okay.
No, no. I think you are, sitting against the light.
Yes, sir. I will
But it,
remove. Now,
yes, now it is, perfect. So thank you very
yes.
much. So I would like to. Now you can formally start the session.
Yes, sir.
Okay.
So I warmly welcome all dignitaries, keynote speakers, resource persons, moderators, and participants to our one-week online international workshop on empirical methods in social science. This workshop is organized by the Jammu and Kashmir Economic Association in collaboration with Jindal Center for the Global South. My name is Ravi Luhar, and I'm working as assistant professor ad hoc basis in Department of Business Economics, Faculty of Commerce, the Maharaja Sayajirao University of Baroda. Now, I would like to introduce our resource person for this session. We are grateful to have Dr. Hersch Sahay with us today, who will share his insights on autocorrelation and model misspecification using R. This expertise will provide valuable knowledge that will enhance our understanding of these important topics. Dr. Hersch Sahay is currently as assistant professor in Department of Economics, Pondicherry University, and a visiting professor at the Great Lakes Institute of Management. Before joining Pondicherry University, he worked at the Narsi Monji Institute of Management Studies, Mumbai. With a 6 year of teaching experience, Dr. Sahay has taught variety of courses, including macroeconomics, microeconomics, econometrics, statistics, mathematical economics, and public economics at both the undergraduate and postgraduate level. He is well versed in time series and panel data modeling using econometric package such as R and EView. In addition to his teaching, Dr. Sahay is actively involved in research areas such as international finance, public finance, inflation dynamics, monetary policy. His research has been published in various journals and edited volume, including work from Oxford University Press and Springer. Dr. Sahay has consistently excelled academically, have won a gold medal for being a top student in MA Applied Economics program and successfully passing the UGC NET JRF examination for his PhD. Now, I will hand over the session to Dr. Sahay. Over to you, sir.
Hello, am I audible?
Yes, sir. Yes, sir. You're audible, sir.
Yeah, thank you so much for that warm introduction.
Yes.
And I first of all like to thank the organizers, the Jammu and Kashmir Economic Association, along with the OP Jindal Global University. I think, yeah, this is clear, yeah. Because, yeah, thank you to all the organizers for inviting me for the sessions. I would like to place on record special thanks to Dr. Baroda and Dr. Firdaus, along with all the members of the organizing team for making sure that the sessions are planned in a very nice and feasible way for all the participants. And thank you to all the participants for joining in after your entire days of work. So today what we'll be doing is as it has spelled out, as has been spelled out already in the brochure, we'll be talking about autocorrelation. We'll be briefly talking about model specification using R and RStudio. And therefore, we have started a bit early today in order to help you understand the entire process of working in R and R Studio and the installation part. Now, can I just get an idea of all of, if you all have at least downloaded R and R Studio? If you have already, or if you have already installed, you can raise your hand, please. Okay, so some of you have done it. So what I will do now is I have purposefully uninstalled R from my system, R and R Studio. And therefore, what I will do is that I'll take you through the steps. So I have the installation files, which would have been shared with you in the morning already. So if you have already downloaded, well and good. If not, then if you can quickly download it in the meanwhile as we are proceeding forward. And let me share my screen so that I can go ahead and run the installation process. I would request the host to kindly allow me to share my screen, please.
IT, it is requested, please allow our resource person to share this.
Done, sir. Done, sir. You have it right, sir, now.
Yeah, thank you so much. So I'll go ahead and share my entire screen as of now so that. So is it visible to everyone? I hope you can see my screen.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Thank you so much for the confirmation. So we have two installation files. First of all, we have the installation file for R, and I would request all of you to first install R. So this is R 4.1, which is the latest version for Windows. So we'll go ahead and run the installation for R first of all. And as it proceeds, you can always interrupt me anytime that you wish, not only during the installation process, but also during the sessions. Wherever you have any problems, you can always interrupt me. So I'm not changing anything. Okay, so I'm just going ahead and clicking next wherever it asks me. I'm not doing anything. I'm just next throughout, next, and it will install R. So first of all, we'll install R. I would request all of you just run the installer setup, the exe file. If you are using Windows, you will have a pkg file if you are using Mac. If you are using any other system like a Unix system or a Unix system, you might have a .rgz file. So depending on whichever operating system that you have, I believe most of you are working on Windows system. Now, can I just get a raise of hand who all are accessing the session through Mac or a MacBook? So I've finished it. Anyone who is accessing on Mac, because slightly the commands and the way to execute them are different in Mac. Okay. Is this software free? Yes. So let me install and then I will take some time to talk about the software. Okay, there are a few who are using Mac, so I will also. So I hope you had downloaded the installer file for Mac as well, and you have been able to install it. Okay, yeah, thank you. So next I'll go ahead and run the installation for R Studio. Please always install R before installing R Studio. And I will tell you the distinction between R and R Studio if you as we proceed forward. So yes, R is here also. I'll go ahead, next, install, that's all. So there is no big mumbo jumbo out here in the installation process. It's like installing any other software that we do on our laptops or computers. Simply run the installer and let it run install the file. So R is a free open source software. Now, when I say free open source, FOSS software, it means that it is freely available for all users across the world to be used. There is no restriction on who can download R, who can use R, and what purpose are we using R. There is no restriction per se. It's open source in the sense that it's there is no restriction on the way that we configure R, like for example, just to give you an idea of a legacy software, like you have Microsoft Office, right? Or Zoom that we are all using for the video meeting. Now, these are all examples of legacy softwares. Now, what is a legacy software? That you have a set of features available, and those are the only features that you can use at any given point of time. And it is only when new updates are released by the owner of the software or the company that manufactures that software will you be able to access new features. Like for example, you have eViews. So I'll click on finish and I'm done with the installation of R in RStudio. Depending on the speed of your system, it might take some more time, or if you would have finished long back only. So I'll continue on with explaining what is R in RStudio by the time that you finish your installation. And in the meantime, I'll just open R. I'll just type in R on my screen. So I have, second, apps. There is some problem with my computer. R. Here I have, if I go down, R. Okay. So this is R 4.4.1. Now, if you have already installed it, you will get, once you go to R, you will get a window like this. Now, I was talking to you about legacy software. Now, eViews is a legacy software because it is manufactured by IHS Markit. And at any given point of time, only those features that IHS Markit has made it available in eViews or configured in eViews that we can use. That is the same thing with SPSS also, and the same holds true with SAS or for that matter, in most of the statistical software that we generally use, or econometric software that we generally use. We have a set of features available that is available to us and we can use them. But in R, there is no problem as such. It's a software where we can ourselves write our own codes. We can make new features available for not only us by writing those codes, but I can create a small chunk of code and give it to you, and you can also use it for your own work, and it becomes part of your R software. Now, at times it's not that that who, in that case the question comes, who maintains R? Is there someone who owns R? No, there is no particular organization which owns R. However, there is an organization. If we just go to the browser, and if I just say owners of R, you can see the R programming language. It is mainly, so yeah, here we can come. Our project is a different website, but I'll just type go to CRAN. Now this CRAN is basically what we say that Comprehensive R Archive Network is basically a group of various institutions, primarily universities and educational academic institutions across the globe, across the world, who manage R. So there is no particular institution which owns R, but there are a group of institutions which simultaneously manage R. And everyone, you and I, can also add in new features to R. And what we can do is that we can write our own programs for doing new techniques, or say, suppose I have designed a new methodology for doing an analysis. I can write R codes for the same thing, whatever we are doing and whatever we want to do, and I can update it to CRAN. That you see, this is a new methodology which we have devised. This is a paper, say, published featuring this methodology in this particular journal. And in order to execute this methodology using this type of data, these are the R functions that I have generated. And these are some example files that we can that are available to help any user understand how to execute those commands. These are some manuals which can help run those commands that I have generated. Now, all these things put together we can create what we call as a package in R. Okay, so packages basically give, or library or package gives the capability to R being open source, that I can create my own package, you can create your own package, and we can submit these packages to CRAN. And what CRAN will do is that it will our paper goes for review process. The CRAN will also review the packages that we have created. They will go through the methodology, the functions, how are they built, are they properly designed or not, everything. They'll review it, and they will release those packages which I have submitted on CRAN for everyone across the world to be used. So what we can see, if I click here on mirrors on the CRAN website, it will show me the list of all the I'm unable to click. Some problem with my, yeah, it has opened. So here you can see for every country, what are the various CRAN like universities which are part of this CRAN system are listed here. If you can see, for India, we have two institutions right now. One is International Center for Theoretical Research, and the other one is NICER, which is there in Bhubaneswar. These are the two organizations which are working, which have their servers which are running R in India. And if I click one more thing here, R sources packages, yes. Now these are the entire list of packages. If I click here, installation, administration, table of available packages sorted by name. Yeah. So you can see these are the various packages, and these, many of them have been created by the members of CRAN, as well as authors like you and I, who have created packages for various types of functions that can be executed in R, and these are available for us to use. Now, this is about the basic idea of what is R. Now, you can see this is the R environment that we call. In the R environment, this is simple R. I'm not getting into R Studio right now. We'll get into that. In the simple R environment, what you can see, there is one window which says R console. And in the R console, you can see a screen blinking here, which basically shows a prompt. And here is where we can do all our execution. So if I write 3 plus 5, it gives me an answer which is just, it acts like a simple calculator. So I can write all the commands and everything in R, and it will give me the result here itself. Now, this R system is what we have to use, but in its basic sense that you can see on the screen right now, and what you might be seeing on your screens, it's not very intuitive to use. It's slightly complicated because it does not give me any help menu much. And it gives me only one screen wherein I have to give input also, I have to give output also. So it becomes slightly complicated. And therefore, what we use generally is we use RStudio, which is nothing but another software which is basically created in order to use R in a more intuitive way. So what we call RStudio is the IDE. IDE stands for Integrated Development Environment of R. Now, when I have opened RStudio first time, it says me which version of R you want to use. Since I'm using a 64-bit machine, which most of you are also using, you can simply click on use the machine default, which is the 64-bit version, and click OK. It's starting up, I think.
So this is final warning to all those participants, whoever, going to open the mic and, disturb the session, I will be keeping him in the waiting room. So I have already told you, we are doing the serious work. So kindly mute your mics. So this is the last warning. Whosoever, I will keep them, in the waiting room. Sir.
Okay, now let me just close these windows. These are my earlier sessions of R which I was using. Now, when you open your R, you will get something like this. Do you see this something here? Let me also clear this part. Yeah. I hope you would get a sort of setup like this when you open R Studio. Now, R Studio is what we call as an integrated. Yes, you don't need to open R always. You can directly open R Studio directly. You don't need to open. So installation first R and then R Studio. Yes. I would request the moderator, sir, if you could please just keep a check on the chat window, because if I open the chat, it will be appearing as a black screen on for the participants. So if you could kindly keep a tab on the chat window and let me know if there are any queries coming up during the session, so that it becomes easier for us to work out. Thank
So
you.
there is a one question. First R, then R Studio.
Yeah. If there are any queries in the chat, just you can interrupt me and ask.
Okay, sir.
Thank you, sir. So I hope you would have got a window like this once you get R Studio installed. Now, in this R Studio window, I would like all of you to first go on File, click on File, New File. Notebook, no, sorry. Why is it opening notebook? Let me just cancel it. For by mistake, I clicked on notebook. It's not notebook, please don't click that. By mistake, I clicked it. Do you click, do you see this? File, New File. And here on the top, first option you see is an R script. Do you see this?
Yes, sir.
Click on R script. If you need a shortcut, it is Control plus Shift plus N. CTRL plus Shift plus N. Now you get, instead of one window, like you could have seen in R, you have now 4 windows like you can see here. Now, what are these 4 windows? So this is what we call as the script, as I have told you. This is like a notepad wherein we'll be entering all the commands. This on the bottom is the console, and this is similar to what you see here in R. Okay, so one window of console is what we have, and therefore all the commands actually get executed here, and the results, most of the results will appear here. This is what we call as the environment. Now, when we'll be loading data, we'll be working with any sort of files. With everything will appear in this environment. And on the bottom, we have a list of windows tabs, which include plots. So whenever we plot a new graph, it will appear in plots. Packages, as I told you, if you click on packages, please click on packages. So it gives you a list of system library. Now, what you can see, these are the packages which come installed when R is getting installed. So these are pre-installed packages which come along with the installer. Okay. Now, these are some of the basic packages which can help us do the basic tasks in R. Nonetheless, in order to do further tasks that we want to do, we'll be installing more packages. And as I told you, packages are nothing but they are collection of functions, examples, data files, some manuals, and which are created for a particular type for undertaking a particular type of operations in R. So I can just give you an example. Right now, you can see that these names are given: base, boot, class, cluster. All these are the packages which are pre-installed. Now, some of the packages you can see will have a tick next to them, and some packages just have a blank. Now, what are these packages which have a tick? These are the packages which are not only installed in R right now, but also loaded in the R current environment, like it's currently available for us to be used. So please understand, if you have used, if you have ever worked with C++ or Java, you will remember that we had to write on the top, we had to write a certain number of commands, like for example, hash include iostream.h, hash include conio.h. If you have used Java or C++ or C anything, C sharp. So all those packages that we were including earlier, it's like we were loading those packages or those libraries for us to be available, that all the functions which are included in those packages can be accessed. In the same way, say suppose, for example, in the same way, for example, let me open just for 1 second. Let me open stats. So this is a stats package. You can see that the stats package has a tick next to it. So if I click on stats, it gives me all the items that are there in the stats package. Now, what are those items? These are, you can see, there are certain functions, for example, ACF, auto and cross covariance and correlation function estimation, computes the AR process exactly fitting ACF. This is ACF to AR. So these are various functions. Apart from the functions, there are certain data also. For example, some packages may include data sets. For example, you can see biplot of multivariate data. So there are some data sets also. And then there are certain example files also which are included. So if suppose if I open one of them, for example, yeah, this one. Now on the bottom, it shows me how do I use this particular function. Examples are given. So every package contains a certain set of functions and data sets along with examples. Now, if I want to use any particular, function which is included in a package, I want that package to be loaded in the environment. For example, let me start by, so I would request all of you also to do what I'm doing so that you can be also on the same page. Now, all my commands I am going to write on the script. Okay. So let me start with a simple thing, calculating log. Okay. So if I write log, now one good thing about RStudio, which is not there in R, is that the moment I write 3 letters, 3 characters of any particular function that I want to use, it will function, or anything that I am trying to, first 3 characters, it will give me a list of all the various options that are available for me to be used. And you can see it says log 10, log 1p, log 2. Now, what are these? These are various functions. And you can see there is a curly bracket in which something is written. Now, this basically tells the package in which this function is included. So log. So log is included in base package, but there is another function called log like, which is included in stats package. Moreover, you can see another yellow window next to, small yellow screen next to, when I go to log, it shows me sort of a snippet of an example file, which show or of a help file, which indicates that how can I call this log function. So it says log x comma base equals to exp1, which means log function, if I call log function, 1 minute, if I call log function, I have to first give the value of x. Now, what is x? You can read on as you followed below. Log computes logarithm by default natural logarithm. Log 10 computes all those things, and log x computes slash log by 1 by x. And if you come here, it basically indicates what is x. The general form log x comma base computes logarithm with base equals to base. So whichever you see the font is there in typewriter type, like you can see that font which is in typewriter type of font, it indicates it is a command which is of R, and otherwise it's something which we can just read like that. Now, what do we want? Log. And what you have to do, simply you open the bracket. And if I write, suppose log 10. Now, how do I execute this? If I simply press enter, it will go to the next line like you do in Notepad. But if you are in a Windows system, please go to this line where you write log. And whenever you are using any function, we use log or the name of the function, and then open the bracket, write, enter the value for which the function will work, which we call as the argument. So log function takes an argument which is equal to 10. Okay, it can take any. So whatever value for for which I want to calculate log, I'm just writing that argument. And please click on either you can click on run, which is on the top here, or what we can do is that press control on the keyboard and press enter. There are few chat items. Have doubt, allow me to ask. Please go ahead.
Sir, how to create this file untitled one? Sorry, I just left that part.
Pardon, sir?
Sir, this untitled one, how you created this?
Oh, untitled. Okay. So what you can do is that, are you using a Windows system or a Mac system, sir?
Windows system, sir.
You can press Ctrl, Shift and N together, or alternatively go to File, New File, and you can see R script. File, New File. On the top, you can see R script.
Thank you, sir.
Now, RStudio, like just as a passing note, has become too advanced right now. Earlier, it was only for R, but right now, even Python commands, everything, C++ commands, HTML commands, everything can be executed in RStudio. So if you are a multi-platform developer and you are working or using multiple software, you can use RStudio as one-stop go for most of your programming needs. Now, moving ahead, as I told you, in order to execute a particular command in Windows, you press Ctrl. I'm holding Ctrl on my window on my keyboard, and I'm pressing enter. On the Mac system, you have to press CMD command and again press return key. CMD plus return. So what will happen is that in the console, the command will be executed and you will get the result of that particular function that we have run, that operation that we have undertaken. Now, this is a case when a particular function is from a package which is already loaded. Okay, so log, if I again write log, just to give you an idea, it says base. Base is the name of the package in which log function is available. And as you can see in the list of packages, base is available. It has a tick next to it. Now, if I want to use another package which is not already loaded, okay.
Please mute your mic.
For example, let me go to survival. Now, just to give you a simple idea, there's a function called AML, or let's take this first function called AAREG. Now, even if I keep on typing here, AAREG, do you see any sort of menu which has appeared like it was appearing for log? It does not appear because RStudio does not recognize this particular function name, which is AAREG, although it is, you can see it is there in this package called survival. This package called survival, it is there, right? In this package called I'll go to the list of packages. There's a package called survival, which does survival analysis, and there's a function called AAReg. But even if I'm trying to call AAReg, I'm unable to access. But how do we do that in that case? We have to use a function called library. The moment I call library, lib, the moment you call lib, it will show you library. What we can do is that I'm using my keyboard arrow, up and down arrow. I'll come to this library option and then press tab. Either I have an option of writing it fully. I can either write the entire thing, or what I can do is, I can either write library entirely like this, or I have the option of lib, just 3 characters that I have to write. So RStudio makes life easy basically. I can come down, press tab key, which is above the caps lock button. Press tab, automatically it will autofill the command name, and the cursor will be available inside this parenthesis in order for me to enter the name of the package that I want to load. So library function, what does it do? It loads packages for it to be used. So I can write here survival. Okay. So I just wrote 3 SUR. It gives me an option. Okay, there is a survival name of package. I'll again press enter. So I'll press tab. So please, I want to make it easy for you to use R, because many people have this problem that R is very difficult because we have to write in a lot of commands. See, you just need to remember some small things, and RStudio makes easy by giving you a lot of options that you can do around. It gives you an option for autofilling your commands, for helping you rectify the mistakes that you do in your commands. Everything is available. So the moment I typed in SUR, it gave me the name of a package that yes, survival is there. And again, once I have entered survival, control plus enter. Now, what do you see? Here again, the prompt has appeared. So please remember, whenever R is working in the background, that it is running some task, this prompt will disappear. This prompt, this greater than sign, will disappear from here. Now, whenever the sign is not available, please never try to execute any command. So whenever you see that this greater than sign is there, which is we call as the prompt, only then you should execute the command. Now, once I have survival package loaded, the moment I write an AAR, do you see AAReg is now getting recognized? So this is what I wanted to make you understand, that even though certain packages are installed in R, it's not available to be used. Now, do you see that earlier survival did not have a tick? Now survival has a tick, and this tick appears when you write in the library function. Now, there is also an option that you can manually, like you can use RStudio not only by using commands, but also like EViews, where you use just click around. Here, what you can do is that you can just click here on, for example, I want to load this particular package, which is called spatial. So I can click on spatial. Automatically, what happens? It executes the command library spatial. Okay, it's doing the same thing, but I would recommend you not to go with to use this method, mainly because of the fact that every package. Okay, I'll first take. There's a hand raised, so let me take.
There is one question from Shruti. Can you
There's
share?
a hand raised, Bhagirath, yes.
Yeah, there is one question from the Shruti. Can you share a list of useful packages for economists?
Okay, see, this is a very, I would rather say that there
Dr. Hersch,
is nothing. Yes,
I'm sorry to interrupt your session.
yes, please.
Bhagirath here.
Yes, Bhagirath, please go ahead.
Yeah, just can you sit a little far away from your screen, because your face is only half visible. Or
Is
you
it
can
better?
adjust your screen accordingly.
One
You know,
second, one second.
because
So,
it is being recorded.
yeah, 1 second. Let me just open. Is
You
it
can
fine
just
now?
put your screen little bit far away, or that should be all right, I guess.
But my problem, Bhagirath, is that if I am very far away from my screen, it will
Yeah,
be
now
difficult for me to see
now
what
it is
is there on
perfect.
the screen.
Now it is perfect. Now it is perfect.
Yeah, I'll try to maintain this distance, but in
No
between
issues.
I'll be coming close and going back because
No issues.
you
No issues.
understand that I
No.
need close proximity for reading.
Yeah, I understand. Thank you so much. Please continue.
Okay. And to answer your question, Shruti ma'am, uh, there is nothing like a list of packages that I can give you. Although once as I am going through the session today and tomorrow, I'll be telling you certain packages which will be loading for certain things that you can use. But R, as I told, it's an open source software, so it's getting updated on a daily basis. So the packages are also getting created and updated on a daily basis. So there is nothing like a definite list of packages that are available only for economists that we can confine to. And since we are using so many types of methodologies right now, there is nothing like a definite list to it. But yes, I will, whatever packages I'll be using today and tomorrow, you can keep them as one of the most important packages which we generally use for basic econometrics. Okay. So moving ahead, I was telling that I would not recommend this method of clicking on the checkbox here for loading a package, because what happens is that, please understand, every function in R is created using certain other functions which are already in R, right? So for example, if I'm creating a function for say average, calculating average of say 100 values. Now average function, it's already there, but let's assume that I am creating a function for calculating averages. Average would require me to first calculate the sum of all the numbers that I have. For that, I will be using another function which is there, which is called sum, which is there in another package, right? Now, therefore, please try to understand, for using a function in my package, I require a function which is there in another package that we call as dependency package. So in order for me to use my package, I also require certain other packages to be loaded and installed at the same time in R. Therefore, if I click on one package checkbox, it may not load all the dependencies together. Therefore, it is always important that you use the library function, because what library function does is that it comprehensively not only loads the given package which I have called in to be loaded, but it also loads all the dependencies that are required for running the functions included in that package. Okay, so I would always recommend, based on my basic limited experience of using R and R Studio, is that you always use this library function for loading packages to be used. But moving ahead, that these packages that you right now see on the screen, again, I think there is, yeah, is it visible, my screen, Bhagirath? Can you please confirm?
Yes, sir.
Yeah, it is fully visible.
Okay, so these packages that you right now see on this list say system library, which basically tells that all those packages which have come along with the R installation are only listed here. But we need a lot of other packages also, and therefore from where will we get? So for that, we must ensure that we are all connected to the internet, like you all are right now, given that we are running a Zoom meeting right now. And then in this package tab, you have something called install. Click on install. Now, when we click on install, there are two options. Either I can install from CRAN, which I told you what is CRAN. CRAN is basically all the set of all the universities across the world which manages R, and in all these universities there is a sort of a web server which is holding a package of R installer
and all the libraries that any user wants to access at any point of time or wants to install at any point of time. So all the libraries, all the installers, everything that is there for R to be accessed and run is there in all these web servers. So I will go to one of these web servers. I don't have to decide. RStudio will decide for me that whichever web server is easily accessible. If we are from India, most probably it will access the Indian servers, which are there in ICT and NICER, or it can access any other server also, which we can change. So I'm not getting into how to change those mirror servers. Let's not play with that right today. But there is also option of installing from a local. Sometimes what happens, your system does not have internet. So what you do, you install, you download all the libraries. From where will you download? I showed you this list of libraries, right? So I can go to one of these libraries and I can download from here. You can see it says you can download package, you can download this R binaries. So I can download the zip files which are required for, which is for this particular library. And the zip file can be downloaded in a system which has internet and then copied and brought in your system. Suppose it does not have an internet, and then like you open any Word file in the same way, you can open like this. A window will appear which will ask me, please tell me where is that particular zip file in my window and in my computer, and I can install it. But again, this also has a problem that dependencies don't get installed. Dependencies are packages which are required for running those functions in the package that I want to install. Therefore, it is always beneficial that you get your computer connected to the internet, which is hardly a problem these days. And you go to first option, which is repository CRAN. Now, what we have to do is that we have to specify where we have to install. Let this also be the default, whatever is there. And here we have to write a list of packages that we require. Now, let me start with one very simple package, which we'll be using today for our autocorrelation and everything, which is called LM test. Now, the moment I write here one particular character, it starts giving me all the packages which contain that particular character in its name. Now, one thing, let me tell you very importantly before I proceed, R is case sensitive. It means a capital L is different from small l. Capital X is different from small x. So capital letter, small letter are different. So be very careful when you are using R, if your caps lock is on or caps lock is off. Okay, right now, by default, we keep caps lock off. And I'm writing this LMTEST. LM test, LM test. Okay, please write LM test and select the first option. Now, LM test is basically a package which contains a set of functions which are helpful for running correlation, autocorrelation tests, heteroscedasticity tests, and a lot of other model specification tests like the reset test and all. Okay, so let's install this LM test package. Now, what do we have to do? We simply have to write LM test. And can you see there is a checkbox also on the bottom, install dependencies. I have told you already about what are dependencies. So if I keep this tick on, which we should always and always keep this checkbox ticked, it will not only install LM test, but it will also install all other packages which require LM test to function properly. Okay, so write LM test and click on install. Now, once you have clicked on install, you can see a list. It will keep on running. And now, apart from system library, there is another thing which has appeared on the package window, which says user library. And in the user library, this contains all the packages or the libraries which we have installed in R apart from the installer. So what you can see, we have installed LM test, but Zoo is another library which is a dependency of LM test. That means in order for me to use functions of LM test, I need other set of functions which are available in Zoo. So not only LM test, but zoo package also gets installed along with LM test. Now, please note that LM test is, I hope you all have been able to install LM test. Anyone who has a problem in installing LM test?
Sir, there is a one question from Divya.
How we choose package to be installed as a beginner? Okay. Now, please understand is that we don't choose which package to be installed. It depends on the function that we want to run. So let's just, and for that, let me tell you, the best way, even though we are running this particular workshop today, and you might have attended host of other workshops for various econometric modeling and everything else. But let me tell you very simple thing based on my experience of being in this field of, let's say, programming. The best way that we can learn any software, and especially programming softwares, is by being able to use the help file. So everyone must always understand how to access help, read help, and understand the help of any software. Okay. Now R has a very good help forum which has been created. For that matter, most of the software right now, you could talk about SPSS, you talk about R, you talk about eViews, RATs, SAS, anything has a good help forum. Stack Overflows are there. There are a lot of other Reddit softwares forums are there. Quora pages are there. But R also has its own dedicated pages of help, which can give you a very good intuitive idea of where to start from. Now, for example, let me just give you an idea. I want to run autocorrelation tests in R. Okay, I want to use a function in order to check autocorrelation. What I will simply do, simple Google search, function for autocorrelation test in R. Now you might be thinking, if you are teaching me to do Google search, why did I join this workshop? But it's important to understand that I'm not only taking you to the Google search, but I'm also telling you how to read that particular page that comes for the Google. Now, there are a lot of this Greek for Geeks has come up, but what I want you to go to mainly doing this R project. Okay, so or let me just do a simple thing, Durbin-Watson test. Let me make it more simple. Durbin-Watson test in R. Okay. Now, yeah, you can see this R project. Let me go to R project or any, because there are a lot of right now, or you can, it's better to go to this rpups.com. There are a lot of online forums right now, but there are few ones which are more reliable. One is something called rpups. There is R project. I can also do, I can write here R project. Okay. Let me come here.
Harsh, it was there. Harsh, sorry to interrupt. Our project was visible in the third or fourth.
Was it visible? Okay, one
Yeah, it was visible. Yeah, this here, search our project. This one, yeah.
So these are some of the reliable paths. So now what do you see? Yeah, this is what I wanted to bring up for you. Thank you, Bhagirath. So now this R project is more like the way that you access help in the R software itself. Now what it shows, Durbin-Watson test. And we want to try to understand what is it. First of all, what do you see? DW test. The moment you see on the top, the first thing tells you what is the name of the function that we need to use for doing this particular test, which is Durbin-Watson test. For Durbin-Watson test, the function name in R is DW test. And as I had shown you earlier when we were working with this log function, the moment you type any function, and next to that function, whatever appears in this curly bracket is the name of the package in which that function is included. So when I see this curly bracket and it says LM test, it indicates that you require to you need LM test package for running DW test function, which is required for running the Durbin-Watson test. Now, for that, what we will do, once you have seen this particular header, simply you will come to R, you will go to package, install, and then you will install the name of the package that appears within this curly bracket. So you copy this and you paste it here, and simply you have to install. The moment it gets installed, you have to call. Now what do you see? LM test is not checked. So even if I call DW test, nothing is coming up. But for that, for me to use DW test, I'll first call library and the name of the package which I want to load. So even though LM test is installed, it is not loaded. So I will load LM test. So you see everything, I'm just writing 3 characters, pressing tab. This is the shortcut. Press 3 characters, press tab. Control enter. Now you see not only LM test has been checked, but zoo also has got checked, right? So dependencies are also loaded when I use the library function. And now if I write DW test, it shows me that I can use the Durbin-Watson test. It's a Durbin-Watson test. Now I hope you understand this particular question. I have been able to answer that. How do we start? Which package to be used? So the decision of which package to be used depends on the functions that we want to use and the package in which that function is available. Okay. Any further questions before we proceed? Okay. So if there are no further questions, what I will do is that we'll install a particular package in R right now, and we will leave it in the background because that particular package takes a lot of time to install. Like it takes around 5 to 10 minutes. So what we'll do, I'll allow that package to run installation in the background, and then we'll move to the theoretical part that I want to discuss with you, which is autocorrelation, model specification errors. And then we'll come back to R once we have done the theory part, maybe for another, say, half an hour, 45 minutes or an hour, maybe at, let's see, if I don't want to spend too much time on theory. And then we'll again get into R and run the same things and see how do we go about it. So I want you all to click on install. Okay. And here, please type AER. Do you see this AER? Even though I'm typing in with a small lowercase character, it shows me that AER is available with an uppercase. So I will click on the first option and it gives me the uppercase option. AER is a package which I want to install, and you can see on the top it says package separate multiple with space or comma. Now if I want to install multiple packages together, I also have that option that instead of only installing AER, I also want to estimate another package which is called CAR. So I will put a space and write CAR. Okay. So I'm installing 2 packages right now. One is AER, the other one is called CAR. Let me install one more package which I will be using tomorrow, which is called URCA. So what I will do, I will just copy this and put it on the chat window for you. So just copy these 3 packages right now. There will be few more packages which I might use tomorrow. And I will, we are doing installation on the go of packages and it hardly takes time. We'll do it. So, but this AER takes a lot of time and therefore I want you to please install on the background. Once you have written, I hope you all have copied from the chat window and pasted there in this installer window. Once you have done that, click on install and you can see, just to show you, The prompt has disappeared right now. There is no prompt on my R console, which indicates that there are background processes which are running. And even though I want to run a code in R, I cannot execute it right now till the time I get a prompt. Okay, all these background processes are running right now. So let me just minimize the R Studio. You can see all these things are getting installed one by one. I hope for all of you, the package installation is going on in the background. In case if any one of you are facing any problem, please let me know. I can help you before we proceed further. It might take 5-10 minutes. So by the time it gets finished, we'll get our theory part done. I'll tell you this package is for what. So we'll be using a host of functions today and tomorrow. So this package contains a lot of other functions which we'll be using for what we will be doing today and tomorrow. So AER basically stands for Applied Econometric Research, Economic Research, and it contains various functions that we generally use. So all your multicollinearity tests and a lot of other tests, lot of data sets which we use for our example setup is there in the AER package. Okay, shall we go ahead? Fine. So before we start, I would just like to note that I was trying to get my pen tab. 1 second, just let me see if it is working, because there is, so that I could use a board as well along with.
So there is a question from the Rupansi.
Yes.
She raised some question in chat box.
I've answered that question. AER is basically it contains various functions which we'll be using for various tests that we want to undertake. It's not working. Just a second. I'm just trying to. Yeah. No, it's not going to work. No problem. Fine. I hope you can see my screen. Is my PPT screen visible?
Yes, sir.
Okay. So I'll not get into other assumptions, but just to give you an idea, among the various, the 10 assumptions of CLRM model that I believe Dr. Bhagirath has discussed with you earlier, apart from multicollinearity, what other tests can be put? We'll come to that. We'll come once we, I'll open the package. I'll show you entirely what is there in AER. There are a lot of things which we may or may not use, but I'll come to that. Okay. So among these 10 assumptions, a very key assumption is the assumption number 8 that I have on my screen, which says no autocorrelation between the disturbances. Now, which basically indicates that the covariance or the correlation between ui and uj given xi and xj should be equal to 0. And this indicates that there is no autocorrelation. Now, I'll skip the entire thing that is already covered, and I'll come to what we have to discuss. And if that particular assumption fails, is what we get as the problem of autocorrelation. Now, autocorrelation, as we have discussed, is the covariance between ui and uj given xi xj. If it is equal to 0, there is no autocorrelation. But if this assumption does not hold true, we say that there is autocorrelation. But autocorrelation, if we want to discuss, we cannot discuss this in its isolation, but there are a lot of other related concepts that we must also understand, which are true in different types of data sets that we want to work with. And I'll give you a practical demonstration of how do we understand autocorrelation. Now, one important thing in autocorrelation, a type of autocorrelation that we call is spatial autocorrelation. Okay. Now, when we are working with cross-sectional data, so for example, you have household survey that we have undertaken, some 500 households of the data that you have. And in that data set, if we find that the subsequent error terms are correlated, and these error terms will be what? These will be basically representative of the various cross-sectional units and households, which are basically distinguished by the geographical space that we have. So what do you mean by spatial? Spatial is basically related to geography. So when the various units, various data units are divided across geography or space, that means we are working with not data which is distributed over time, but data which is distributed across space, which is basically the cross-sectional data. Then we will say that autocorrelation is of the type of spatial autocorrelation, because there the covariance will be observed between the individual cross-sectional units. So when covariance is between ui and uj, where I not equals to j, this is called spatial autocorrelation. Now, just to give you a very simple idea, okay, let me just switch off for a second. Okay, let me come back to my home screen. I want to open Excel and show you one simple thing. Many of you understand this. Some of you may or may not be aware, and therefore let's try to understand this entire process of what is ui, what is uj, what is ut, what is ut minus 1. Because when we work with autocorrelation, we say that when there is correlation between ij or tt minus 1, what is this? Now, suppose, let me think of a very simple example. Okay, let me take this simple data. Okay, I have y and I have another variable x, and I am running a simple regression using these two variables. I will not use R right now. Let me use simple Excel regression, because here my objective is to show you what is error term and how do we work with the differential types of error terms. So I'll simply go to data in order to estimate a simple regression model. I hope you all know how to run regression in Excel. So here is a data analysis tool pack of Excel, regression. And in the y variable, I'm putting y. So this is not something that is part of my session, but I'm just doing it in order to help you understand what is this concept of autocorrelation all about. So I'm just regressing y on x, labels are there, and I want to store the output somewhere here. And I also want residuals to be estimated along with it and displayed. I'll click OK. Now you can see the results have appeared, and along with that, the residuals we have got. So when we do the estimation or regression in Excel, we have an option of getting y hat or y cap, what you call predicted values of y, along with the residuals. Now, what do you see? These are the residuals, which are the various, which is the u term, right? So if I copy this, let me just copy this entire thing. One second, let me auto hide this. Yeah.
I was trying to hide the Zoom controls so that I can switch. Now I'm pasting. I'm copying this error terms, the residuals, and I'll paste here. Now, what are these? These are basically what you call as U, right? Now, if I have these observations as 1, 2, up till say 10 observations. So what you basically have, this is U1, this is U2, and you have U3, U4 up till U10. So this U1, U2, U3. Now, what are we basically interested in? So when I say that if there is covariance between Ui and Uj where I not equals to j, what does it mean? It basically means that the U, which is basically, suppose if this is Ui, which starts from U1, I want to generate another Uj, which is not Ui, but it can be anything which starts not from U1, but maybe from U2, U3, anywhere. One of the example is I can have this value here and then I scroll it. So what do you see? The first U1 becomes U2 here. So now what do you see? This entire series, this if I call it as U1, where the starting point is U1, this Uj will be U2 because the first point here is U2. So if I want to calculate the correlation between these two series, if I want to calculate is equals to correl comma the second, this value is basically the correlation or autocorrelation which exists between these residual terms that we have estimated right now. So there is a negative autocorrelation between in this particular data set that I have used. Now, just to help you understand, if this, since this is a cross-sectional data, this is a cross-sectional data. Now, in this case of a cross-sectional data that I was working with, this is a cross-sectional data. The correlation that I have calculated between Ui, which is suppose I equals to 1, and Uj, where j equals to 2, Ui and Uj correlation is not equals to 0. I have to again test the statistical significance that will come later. Let's assume that if it is non-zero, we'll say that this is a case of spatial autocorrelation because each of the observation represents a cross-sectional unit. So this is basically checking if, suppose if y is the consumption variable, x2 is the income variable, x3 is some other variable which indicates say let's take some sort of price of certain goods that we are purchasing. So if I'm estimating a function where I have consumption as a function of income and price of certain goods, in or this is say price and this is the income. In that case, what we are saying, this is the residual basically indicates that value of consumption. So for any regression model, what does the residual indicate? So residual basically indicates that part of the y variable or the dependent variable which has not been accounted for in the model. Now, if I have accounted for price, let's take x2 is price, x3 is income. So since I have accounted for consumption as a function of price of the commodity as well as the income of the individual, what does U indicate? It basically includes, or it basically indicates that part of consumption which is found irrespective or which is found or which is due to all the factors which can cause consumption to change apart from income and the prices, right? So this is basically indicating these particular values that you see. These are basically the consumption, the residual consumption of the people after accounting for the changes in consumption due to price and income, right? Now, this indicates consumption in its first place. So this is the consumption of say
household 1. This is the consumption of household 2. This is the consumption of household 3, and so on and so forth till household 10. So when I calculate U2, which is basically I'm taking first observation and placing it next to the second observation. This, please understand, is the consumption of first household, which is pitted against or which is kept against consumption of second household. So what we are doing, we are checking if there is any correlation between the consumption of first household and the second household, right? So this is the consumption of second household and third household. So I'm checking if there is any relation between my consumption, if I am one household number 1, if my household consumption is anywhere related to my neighbor's consumption, that is household number 2. If there is any sort of relation, like we have a demonstration effect or a Veblen effect working, which we call in microeconomics, right? That if I have bought an AC or if I have bought a luxury car, my neighbor will also go and just want to imitate my behavior. They will also undertake a similar consumption. So if such sort of consumption activity occurs to indicate a Veblen or a demonstration effect, we will see what we call as a spatial autocorrelation, where in a cross-sectional data, there will be a relation between the residuals obtained between the residuals that we have got, and once the residuals are, when we take a lag of the residuals, that means they are compared again against the residuals obtained from other households that we get. It's not only, so when we compare between first household and second household, we are calculating first order spatial autocorrelation, okay? Alternatively, if I would have done equals to this, and if I run this, and then I suppose, one second, is equals to the first one, and then I extend this further. Now what happens? This becomes U3. Now what is this U3? I'm comparing, if I want, now if I check the correlation between this set and suppose this particular set, what happens? I'm comparing the consumption of the third household with the first household. So after leaving one household, I'm comparing the consumption behavior. So what happens? This is what we call a second order spatial autocorrelation. Now the same thing will hold true if I would have time series data. So if I had time series data, what happens? Instead of cross section, suppose if the same data, if we are assuming is time series. So if this is, let's take 2000, the year 2000, this is 2001, and then it goes like this. So in this case, what happens? I am comparing, when I check the correlation here, I am comparing whatever is the level of consumption in the year 2001 with whatever was the consumption in the year 2000. So when I compare the consumption, which is basically the residuals which are part of the Y variable between the current period and the past period. Past can be any length of past that we can compare. So here when we, between U1 and U2, when I take, this is 1 period past. When I do U1 and U3, it is 2 period past. I could have, say, n period past depending on whatever is. So suppose if I have, suppose 10 observations here, I can compare at the max till 8 periods past, because for correlation calculation, I need at least 2 observations in both places, right? So 8 period past, what was the value of consumption versus what is the consumption today, how is it changing, can be calculated. So if I'm working with cross-sectional data, we call the same concept as spatial autocorrelation or spatial correlation. When we are working with time series data, we call it autocorrelation, where covariance is checked between UT and UT minus S, where S not equals to 0. So when I'm saying T minus S, it is T minus 1, T minus 2, T minus 3. So if this is UT, you can see this is UT minus 1. T minus 1 means this is UT, this is UT minus 1, this is UT minus 2, UT minus 3, and so on and so forth we will get. Now suppose if I have a panel data, or we have 2 separate time series data. So I can check the correlation between, whatever is the So suppose if I have panel data, so in that case, I can check whatever is the correlation between two cross sections of a panel versus two time periods. So suppose what happens in the month of January, okay, I have, let's assume, let's take a panel data where 20 households in a locality have been surveyed over 24 months. 20 households in a locality have been surveyed over 24 months. So in the month of January, if household number one's consumption increased because they bought a car, let's take an air conditioner, let's take a new, they have bought a new air conditioner in their house. What happens in the next month, in the month of February, the second household will also go and purchase an air conditioner. So what happens? My consumption, household number one's consumption in a given period affects another cross section, which is household number two's consumption in the next time period, which gives rise to covariance between I and J. So when I say IJ means two different cross sections separated between two time periods, there is some level of autocorrelation. Then we say that this is the serial correlation. Or if I have two different series, if I have two different series, one is giving me a residual of U, other is giving me a residual of V. And if both these series, which are coming from two different regression exercises, are linked over two different time periods, please understand time periods must be different, then also we say it's a case of serial correlation. Or we can have what we call as contemporaneous correlation. Now, contemporaneous correlation is strictly for panel data only. And what do you mean by contemporaneous in English? It comes from the root term contemporary. Contemporary means at the same time. Who are contemporaries? We say that, like we can say right now, that let's say certain actors are contemporaries of each other. Shah Rukh Khan and Salman Khan are contemporaries. So they both they started their journey around the same time, and then they are working in around the same time. So they are contemporaries. So if we, in a panel data, if we find that two households, let's take two cross sections or two countries, are showing some level of correlation at the same time. So if the exports of India are in the year of 2023 is related to exports of let's take Vietnam in the same year 2023, and if I have a panel data of say Asian countries, and I have 20 years of export data for the Asian countries, East Asian countries, Southeast Asian countries including India, Vietnam, China, Myanmar, say Indonesia, and all those countries together. And if I find that the exports of India for 2023 is related to exports of Vietnam for 2023, same time period, contemporaries, but across two different cross sections, then we say that it's a case of contemporaneous correlation. So these are some of the related concepts that we generally, that we interchangeably use. So when many of the books, they will interchangeably use these terms, but you need to understand the differences that we have between these terms and where do we exactly use these terms, depending on the type of data that we are using and depending on the type of situation that we are confronted with. Any questions in this particular slide before we proceed?
Sir, there is one question in chat box.
Okay, let me just check that. Apart this, we have taken up, I told. So please repeat contemporaneous correlation example. Okay. I think I'm getting, there's a lag for me to get the question. So contemporaneous correlation. Now contemporaneous correlation, as I told, it relates to it's basically true for panel data, point number one. And in panel data, we know that it's a combination of cross section as well as time series, right? So suppose if I have an example of a panel data where I have 20 Southeast Asian countries, or let's not take 20, let's take some BRICS nations, okay, 5 BRICS nations, and we have data on exports of BRICS nations, or let's take CO2 emissions of BRICS nations over the past, let's take for the past since 2000. So last 23 years of data on CO2 emissions for BRICS nations that we have. Now, in that case, when we want to keep the time fixed means for the same year, let's take for the year 2022, if we observe that the CO2 emissions between Brazil and Russia, or Brazil and China, or India and China, or India and Russia are related. So I have data on India's CO2 emission for 2023, and I have data on Russia's emission for 2023. Those two data sets when we have, and when we calculate the correlation, we find that yes, they are related. Okay, so if that is the case, okay, then we say that it's a contemporaneous correlation. So at the same time across cross sections. Serial correlation was across cross sections across time. So if my consumption is related to my neighbor's consumption, but not in the same time period across different time periods. The current year's consumption is related to next year's consumption. So if India's exports in the current year is related to Vietnam's export in the next year, or Bangladesh's exports in the next year, it's a case of serial correlation. Is it clear now? Okay. So what we'll do today is we'll discuss about autocorrelation in its very basic sense today. We'll be dealing with first order autocorrelation today, and then tomorrow I have a session on time series, basics of time series. There we'll explore higher order autocorrelation and how to work and detect higher order autocorrelation and work around that. So that task we will keep for tomorrow. Okay. So today we'll stick with first order autocorrelation. Now, why do we get, so we have understood what is autocorrelation. Now next comes the question is, why do we get autocorrelation? Now there are various reasons for autocorrelation to exist. First of all is inertia in the data. Now what is inertia? Inertia is basically once a particular variable is increasing in value, it tends to increase for a certain period of time before it will start decreasing or start slowing down in its value. For example, a very good example is what you can see on your screen is a stock price data. So these are closing Nifty 50 prices. Now, what do you generally see? And from your own understanding, I believe that many of you, even though are not investing in stocks, which I also don't do, but you would have definitely watched the way in which Sensex or Nifty or any of these indices behave. What happens? Suppose there is any sort of a news which comes in, like you remember some 3 weeks back when there was a news of Fed going to cut the rates, there was a sudden fall in the stock returns in most of the Asian economies. And once these prices start falling, let's take they are falling, it's not that it will stop immediately. They will continue to fall for certain periods. So depending on the frequency of data, suppose we all know that generally stock price data or this equity data is high frequency, and we get data even to the extent of 2-second duration, ticker data, what we call it. Every 2 seconds, you have a new value of stock prices. So in such cases, we know that if suppose there is a positive news of a Reliance announcing a bonus 1:1 payout of shares, bonus share payout, suddenly the prices of Reliance shares will start increasing. Now, in that case, every 2 seconds that you track the prices, it keeps on rising. Even if you track every 5 seconds, every minute, or every hour, it will show an upward trend for certain periods before which it starts sort of reversing its path in the negative direction or in the other direction. Even when we saw Fed cutting down on its rates, the stock prices started falling for consecutively 2-3 days. I think it fell down for 3 days, if I'm not wrong, 3 or 4 days before it could go back into green. Certain stocks remained red for more than 4 or 5 days, like the entire almost a week they were red, right? So this sort of inertia that we observe, that whatever is the value that we observe in a particular variable at a given period is not only dependent on, is not independently observed in that period, but it depends on what has happened to that particular variable in the past, right? So if the stock price had increased in the past due to a certain external shock, it continued to rise for certain periods. So such sort of an inertia or momentum, when it builds in the data, it leads to a case of autocorrelation. Now, please understand that in its basic sense, what do we want? We want every observation of the residual term to be independent. In the sense, we want the expected value of every ui given xi to be 0. One of the key assumptions, if you remember, of this CLRM is this something here, right? What do we have here? 0 mean value of disturbance. Expected value of ui given xi is 0. What does, and this is very important that please know. It means that every residual term for every xi value, the residual terms for every xi value should have a 0 mean, right? Now, it means that every residual value, so here when you see this residual that I have observed for the year 2000, this residual which I have observed for the year 2001 should be completely independent of whatever would have been the value of the residual term in the previous year or in the future year or any period in the past or any period in the future. So every residual is independently observed. But if these residuals are not independently observed, in the sense that the past value of the residuals had any impact on the current value of the residual, because of inertia building in the data, it will lead to a problem of autocorrelation. Because what will happen now, if my past consumption is impacting my current consumption, so past consumption has an impact on current consumption, then what will happen? There will be some level of autocorrelation. Okay. Another problem of autocorrelation or reason for autocorrelation to exist is specification bias. So whenever we commit any error in specifying the model incorrectly, it will lead to a problem of autocorrelation. And this is the second part which we'll be discussing today, the problem of model specification. And therefore, I'm leaving this part as of now. And when we get into model specification, we'll discuss that in more detail. What is specification bias? So generally, if I have a particular variable that should have been included in the set of regressors, that means among the X variables. So for example, you are estimating a money demand function. We know that money demand is a function of income and interest rate. Or let's take demand of a particular commodity, a more simpler example. Demand of a particular commodity is a function of price of that commodity, income of the individuals who are consuming that commodity, prices of substitutes, complements, taste and preferences, right? If I miss out on certain variables that I should have included, if I miss out on price of the commodity as one of the independent variables or the regressor, in that case, what will happen? It will be a case of incorrect specification and it will lead to autocorrelation. Okay. Then incorrect functional form. If we have, so all these both are cases of incorrect specification. If I'm estimating a profit function, we know that profit functions are generally quadratic or cubic in nature. But if I estimate a linear function of profit, it will lead to a problem of, again, autocorrelation. Then we have cobweb phenomena, which is basically true for agricultural prices, or for that matter, whenever the past prices affect my current output. If we are estimating any sort of a model wherein we observe some sort of a cobweb phenomena, it will lead to autocorrelation. Further lags. So when we are working with time series data where my current observation is a function of past observation, like you have this equity share prices, then again we have a problem of autocorrelation. Non-stationarity, I'll discuss tomorrow. There is a question. Please explain specification bias. I'll explain specification bias in more detail, because That is the second part of my lecture today. But the idea basically is, if there is a particular variable that you should have included, but if you left it out and you have not included that in the model, then it's generally a case of specification bias. Or sometimes if we have over parameterized the model, that is also a case of specification. I'll discuss that in more detail. Please hold for a few more minutes and I'll come to that. Now, these are some of the causes of autocorrelation. What are the causes? One is inertia in data. Second, and when will data have an inertia? When, first of all, it's a time series data, we'll observe some inertia. Or if we have some sort of a Veblen, or demonstration effect working, we'll have some inertia. When we are working with price data, we'll have cobweb phenomena that will lead to inertia. When we have incorrectly specified the model, we'll have a problem of autocorrelation. Or if we are incorrectly doing a data transformation, for example, if I'm extrapolating the data or interpolating the data, for example, if I have quarterly data, which I'm converting into an annual data, into a monthly data. So what will happen in such cases, if I have not correctly done the process of interpolating from quarterly to monthly, or going from monthly to say annual data, I am doing some sort of an interpolation of data. Then if the techniques are not correctly used, what will happen? All these monthly data put together, suppose conversion from monthly to annual. So what happens if annual data, if I'm working with some sort of a stock, not stock variable, but let's take a flow variable, which is GDP. So what is GDP? It is the sum total of value of all the goods and services produced in a year in an economy. So if I take the sum total of all the GDP of quarterly GDP, it is annual GDP. But if I do not add the quarterly GDP correctly, what will happen? The sum of the GDP which comes in the annual GDP will be incorrectly estimated. So such sort of data transformation, incorrect data transformations can lead to autocorrelation also. Non-stationarity is again a very typical case of time series data, which we will discuss tomorrow. So non-stationarity is generally observed in data which has inertia, something like this. So when data keeps on increasing without getting back to the mean value, then we say it's a time series data. So whenever you observe a data like this, something like the data keeps on rising in a particular direction, trending data. Time series data generally are trending in nature, right? Upward trend or downward trend. We say those are generally non-stationary data. So non-stationary data which will have inertia will have some sort of autocorrelation. Gaps in data may not. So when you have gap in data, what do? You generally go for some sort of interpolation, right? So if you are using, say, suppose if the data follows some sort of a cubic splining methodology, which given that data is more of non-linearly changing, but if you use a linear method of interpolation, linear transformation, that can cause some sort of autocorrelation. So gap in its sense will not cause autocorrelation, but if you are using a wrong method for filling those gaps, then it can lead to autocorrelation. Any further question? Interpolation is same as underestimate. Not exactly. Underestimate is more of the case if in a regression model, if the value of your parameter is less than what should have been the actual value of the parameter. Interpolation is more of when you are filling up the data that you have, and there are different methods for depending on the type of data distribution that we are working with. If it can be a linear transform, so if the data is rising in a linear scale, you can use a linear transformation. If it is behaving non-linearly, like sometimes it is increasing at an increasing rate or increasing at a decreasing rates, then we can use some sort of a cubic splining, or we can use some sort of a Levin-Lin procedure. So that is a discussion for a different day. No, non-stationary is not gaps, sir. Non-stationary we'll discuss more tomorrow in detail, but for your basic understanding, you can understand that if a particular, so for example, if you see this particular data set, what do you see? Here, it's rising continuously. It's not rising and falling. So it's if I see in its whole, there's an upward trend that you see in the data. There is no, it's not for if you compare this with another data set. Let me just show you another data set. 1 second. Okay, I don't have that. My computer had malfunction, so I'm not able to. Or wait a minute. Let me show you. I think I will have that. Just to give you a reference, what is comparison? Okay. Wait, I'm able to see where is my. Okay, I don't have that particular, otherwise I could have times. We have that. No, it's not there. Okay, sorry. I'll show you. We'll discuss that in detail tomorrow. I thought that I might have that particular PPT right in front of me so that I can show you what am I trying to tell. So this is more of a upward trending. So this is when you have a series which increases continuously. Sometimes you will see like for example, if you would have seen, let me just draw it otherwise. Do I have an option of pen? Yeah. Suppose I have a data which looks something like this. Do you see this? It's rising up and falling down, right? So around the central mean value, it is rising and falling, something like this, like a seismograph, like you generally see these earthquake seismic graphs, right? So if you get a data like this, generally you will observe inflation data, which behaves like this. Then we'll say that it's a case of stationary data. But here, what do you see? There is no pattern. There is no continuous upward or downward trend. It is just going up and going down, and it is oscillating between upward and downward positive and negative values. This is what we call as what we call as a stationary variable, and the one which is in red. And what you see in blue, which is the equity Nifty 50 prices, is what we have as the non-stationary data. Does it make sense? We'll discuss this in more detail tomorrow. Okay. So moving ahead. Now, what we are saying is that given that UT and UT plus S or UT minus S, anything, right? It's like the future values are related or the past values are related. If they are not equal to 0, can we define UT as a function of its past value? So if you remember the setup here, what I was telling, that if this is the current value of the residual terms, if this is related to the past value of the residual terms, if these are not equal to 0, if the relation between UT and UT minus 1 is not 0, can't we define UT as a function of UT minus 1? If so, if we can define that, can we write UT as a function of UT minus 1, where rho defines the autocorrelation coefficient, or we call it as the coefficient of autocovariance between UT and its lag. So UT and UT minus 1 are related by this term rho. Now, what do we observe is that if there is autocorrelation, so rho value will be between -1 and 1, because we know that correlation, if you calculate the Carl Pearson's correlation of coefficient of correlation, it lies between -1 and 1, and hence the value of rho will also lie between -1 and +1. because if rho equals to 0, which means ut minus 1 does not have any impact on ut. So it is no autocorrelation. But if rho is anything different from 0, if it is significantly different from 0, either negative or positive, it indicates that ut has an impact, or ut minus 1 has an impact on ut. The past has an impact on my current value. And therefore, we say that there's a case of autocorrelation. If rho is negative, we say it's negative autocorrelation. If rho is positive, we say it's positive autocorrelation. Now, in the presence of autocorrelation, what happens? Now, we have understood what is autocorrelation, what causes autocorrelation, and now we'll try to understand what happens if there is autocorrelation. So if there is autocorrelation, what happens? That this is what the formula that you might have seen, which is the formula for variance of the beta 2 parameter. If I'm running a regression of yi equals to beta 1 hat plus beta 2 hat xi plus ui. So if I'm running a regression of y on x, where beta 2 hat is the parameter related to x, so the variance of beta 2 hat is generally given by sigma square upon summation of xi square. But if there is an autocorrelation, if there is no autocorrelation, this is the formula. But if there is autocorrelation, the variance is now no longer equal to this formula, but it is equal to this multiplied with 1 plus r rho divided by 1 minus r rho, where rho is the coefficient of autocovariance and r is basically the coefficient of covariance, coefficient of correlation between the x variables. So if you have x1, x2, x3, multiple x variables on the right hand side, all the correlation between those x variables is equal to r. Now, if you have only one x variable, which is y as a function of x, in that case, what will happen? R will be non-existent and it will just be equal to 1 plus rho upon 1 minus rho. Now, please understand, rho is a fraction between minus 1 and 1, right? Rho is a fraction between minus 1 and 1. And therefore, what happens is, let's take a value of rho to be equal to 0.5, right? So what we'll get, if rho is equals to 0.5, let's take r is non-existent, it is equal to 1. If r equals to 1, rho is 0.5. So we will get 1 plus 0.5 divided by 1 minus 0.5, which is equal to 1 plus 0.5 divided by 0.5 is a value which is greater than 1. One plus 0.5 divided by 0.5 is 3. 1.5 divided by, on the denominator, I have 1 minus 0.5, which is 0.5, it is 3. Now 3 is greater than 1. So what happens? The calculated value of the variance of beta 2 hat, variance of beta 2 hat is greater than what should have been the variance if there is no autocorrelation. So what generally occurs is the variance of beta 2 hat or the OLS estimator gets increased in the presence of autocorrelation. And therefore, if the variance is not equal to its true variance, if the variance of the estimated parameter is not equal to its true variance, which property of blue are we getting problem with, or are we doing away with? Can anyone tell me this? Or which blue property is violated? So what I'm saying, if there is autocorrelation, if rho is anything not equal to 0, if rho was 0, 1 plus 0 upon 1 minus 0 is 1 upon 1 is 1. So variance of beta 2, when there is autocorrelation and when there is no autocorrelation is the same, because autocorrelation will be equal to, this rho will be equal to 0 when there is no autocorrelation. But if rho is anything which is different from 0, then this value, this variance, calculated variance in presence of autocorrelation will be higher than what should have been the variance. In that case, which property? Yes, the minimum variance property gets violated. We won't have the estimators which are best, and therefore we will have inefficient estimates of the beta parameters, right? So we will have inefficient estimators, and that is what it is written, the beta 2 calculated will become inefficient. Okay. Now the question arises, how do we test if there is autocorrelation or not? Now there are various tests. What I will focus on is the Durbin-Watson test, and which is most probably used. I'll discuss with you the basic D test and also the H test, which is there in R. Okay. And we will estimate the H test and I will show you in R. Now, the Durbin-Watson test has certain assumptions that must be taken into consideration whenever we are using the Durbin-Watson test. Okay. The first and foremost consideration is that whenever you are using a Durbin-Watson test, the original regression model that we are using for the Durbin-Watson test must have the intercept term. That means yi or yi should be a function of beta 1 plus beta 2 xi. It should not be yi as a function of yi is equal to beta 2 xi plus ui. The intercept term must always be present. That the constant term should not be absent. That is one of the most important considerations that you must remember. Second thing, which there are other things also, but second thing which we must understand, there should not be missing observations in the data. Because if there are missing observations, Durbin-Watson test cannot be run or estimated. Third, which is more important, there are a lot of other things. Third, which is more important, is that we assume normality of the error terms. So before we use Durbin-Watson test, it's generally advisable, which we many a times don't do, but it is generally advisable that we use some sort of a normality test in order to see if the data that we are estimating, generally the y variable that we are estimating, follows a normal distribution. So something like a Jack-Barra test can be used for testing normality before we go for the Durbin-Watson test. And more importantly, Durbin-Watson test, D test, that there are different types of Durbin-Watson test. There is a Durbin-Watson D test, H test, modified Durbin-Watson test, M test. So the D test that we use for Durbin-Watson is only and only meant for first order autocorrelation. For testing first order autocorrelation, in the sense, if in the data that we are using, u is related to u minus 1, ut is related to ut minus 1, or ui is related to uj, where I and j are distanced by only one period. So if and only if I want to see the autocorrelation between u1 and u2 or u2 and u3, I can use Durbin-Watson test. If I want to check if there is autocorrelation between u1 and u3, Durbin-Watson test, D test cannot be. Okay. Now, a very basic sense, what we do is we run a simple OLS model. We run a regression model, capture u, which is the residual terms, and use this formula for calculating. I'm not going to do this today. I use what we have as the in R. How do we do that? I will show. But to help you understand the interpretation of this D, now the value of D can be understood from this formula. Okay, not to get into the derivations. If we were here for an entire class of autocorrelation, we would have got into derivation, but just focus on this part, this particular part. You can see my cursor. D equals to is approximately equal to 2 into 1 minus rho hat, which indicates that the value of D is approximately equal to 2 into 1 minus rho hat. Now you remember what is rho hat? It is the coefficient of autocovariance, which lies between minus 1 and 1. Now if rho hat is 0, what is 0 means? Rho hat will be 0 when there is no autocorrelation. So if there is no autocorrelation, what happens? If rho hat is 0, 1 minus 0 is 0. Sorry, 1 minus 0 is 1. 2 into 1 will be 2. So in case of no autocorrelation, the value of Durbin-Watson D statistic will be close to 2. Okay. But if there is autocorrelation, if there is positive autocorrelation, so if there is positive autocorrelation, let's take the value of rho will be close to plus 1. So if the value of rho is close to plus 1, let's take it as equal to 1. So 1 minus 1 is 0. 2 into 0 will be 0. So in case of positive autocorrelation, the value of D will be close to 0. So if there is positive autocorrelation, D is close to 0. If there is negative autocorrelation, let's take if the value of rho is minus 1. So 1 minus of minus 1 will be 1 plus 1, minus of minus is plus. So 1 plus 1 is 2, 2 into 2 is 4. So D value will be 4. So in that case, the value of D statistic in case of negative autocorrelation will be close to 4. So value of, just to summarize, value of D is close to 0 when there is no autocorrelation, close to 2, no autocorrelation, close to 2 when there is no autocorrelation, close to 0 when there is positive autocorrelation, and close to 4 when there is negative autocorrelation. But if we are working in R, what we use is what we call as the H test. Now, what does the H test do? It uses the D statistic, but it also allows H, the formula for H is 1 minus D by 2 root over N minus 1 minus N variance of beta 1 hat, where beta 1 hat is basically the coefficient related to the lagged term on the right hand side. So in this case, this is not something for you to very much understand, but here is what we want to understand. Now, in case if D is no autocorrelation, forget about this root over part, just focus on this part, 1 minus D by 2. Now, if D value is 2, it means I told you no autocorrelation means D is equals to 2. So in that case, what will happen? 2 by 2 is 1. 1 minus 1 is 0. So in the case of no autocorrelation, H will be close to 0. And therefore, H follows a normal distribution with 0 mean and 1 standard deviation. So it follows basically a standard normal distribution. So in case of no autocorrelation, H value will be 0. In case if there is positive autocorrelation, do you remember what is the value of D for positive autocorrelation? Positive, it is 0, right? Close to 0. So in this case, what will happen? 0 upon 2 is 0. 1 minus 0 is 1. So H will be greater than, so 1 minus 0 is 1. 1 is greater than 0. So H will have a value which is 1 into this number. If this is a value which is higher than 1, then you will have a large value. So in case if H is positive, it is positive autocorrelation. In case if it is negative autocorrelation, here it is written everything on the bottom. In case of negative autocorrelation, D is 4, close to 4. So 4 minus 2 is 2. 1 minus 2 will be minus 1. 1 minus 2 is minus 1. So this entire term, root over of this entire term will be positive. So positive, which is multiplied with a negative term, will be negative, and therefore H will become negative when there is negative autocorrelation. So here the interpretation becomes easy, because if H is 0, no autocorrelation. If H is positive and significant, positive autocorrelation. If H is negative and significant, negative autocorrelation. And this also helps this H test, because in D test we have something called zone of indecision, where if the D value falls between the ranges of zone of indecision, we cannot say if there is positive or negative or no auto. We cannot infer if it is positive or negative or no autocorrelation. But in H test, we have a surety. In the sense, if it is insignificant, if the value of H is insignificant, so when we run the H test, you will get a value along with its p-value. So if p-value indicates insignificance, no autocorrelation. If H is positive and significant, that means positive autocorrelation. If H is negative and significant, negative autocorrelation. Okay. Any queries in H test? Nothing? Okay. Now comes the case. This is about testing. Okay. Correction we'll do later. But I'll come back to this problem of model specification. So correction, we generally, as I told, I'll come to correction mainly because this is somewhere related to the source. And one of the key sources of autocorrelation or causes of autocorrelation is wrong specification. So one of the one of the key ways of correcting for autocorrelation is correcting the specification of the model. So if we correctly specify the model, autocorrelation in most cases gets eliminated. But if autocorrelation is not getting eliminated even after the model is correctly specified, what we can do is that either we can add the dependent variable as regressor. So if I have yt as the dependent variable, I can bring in regressors as yt minus 1, yt minus 2, like that, a lot of variables. Why so? Because it basically works on the idea that the lagged, so if, I'll discuss this part when we finish error correction, this model specification, but hold it for now. Okay, I'll come to this specification error. Now, specification error, as I told, I'll mainly focus on, there are lots of specification errors, but mainly I want to focus on the first 2 or 3. One is omission of relevant variable. Second one is inclusion of unnecessary variable. Now comes some of you people were asking this specification, please explain. Let's try to understand. If the correct model is given by the first equation, yi is a function of beta 1 plus beta 2 x2i plus beta 3 x3i. So what we are saying that in order for the model to be correctly specified, y should be specified as a function of both x2 and x3. But suppose if as an econometrician or as a researcher, I have not adhered to the theoretical model correctly, I have not taken into consideration all the theories which are relevant for specifying my model. I have not read all the papers, like all the relevant papers that have discussed this particular topic and all the empirical papers that have estimated a model, and I'm missing out on certain variables that should have been included in the model. What will happen? I will incorrectly estimate a model by excluding a key variable x3. Okay. Now, what happens in such cases is that if x3 is at all an important variable, that means x3 has a significant impact on y. So by excluding x3, the new error term, which is vi, will now include x3, because please understand what is the role of error term. Error term includes all those factors that can cause y to change, which are not included in the model. So if x3 actually has an impact on y, let's take a small example. If I'm estimating a model for GDP growth, okay, GDP growth is a function of inflation rate, is a function of say domestic growth in domestic investments. It's a function of let's take growth in money supply. Let's take only these variables. Okay, 3 variables. One is inflation rate, domestic investment, and what was the third variable I said? Domestic investment, and let's take interest rate. Okay, interest rate. 3 variables: inflation rate, interest rate, and domestic investment. If these are the 3 variables which affect GDP growth rate. Now, in case if I have correctly specified the model, my UI, which is the error term, the mean of the error term will be 0, because it will be independent. It will be independently distributed. No zero mean of error term will be ensured. But if I omit inflation rate by not including inflation rate in the model, what happens? VI, which is the error term from the incorrectly specified model, will now include the impact of inflation, because inflation is an important variable that has an impact on GDP growth. Now, in this case, if VI is included in the if inflation is included in the error term, what happens? The mean of the model which is incorrectly specified will no longer be 0. Why is it so? Because the mean of VI includes mean of UI plus mean of this inflation rate, which is non-zero. We know that at least in India, the mean inflation is somewhere around 4%. So in that case, the mean of the error term VI, which is from the incorrect model, will be close to 4, but not close to 0, which would have been the case. So if whenever you find that the error term, the mean of the error term is non-zero, it is significantly different from 0, you have to suspect that the model is incorrectly specified. So a very good way of checking model misspecification is please check the mean of the residual term of the model to see if the model is misspecified. Or what do? We check for autocorrelation. Why? Now I'll come to that. I'll come to that part. But before we go ahead, let's try to understand the difference in these two models. If we have incorrectly specified the model, like the second model, instead of using the first model, alpha 2, which is the estimator of, which basically captures the impact of x2 on y, is no longer equal to beta 2. Why so? Because beta 2 in the correct model captures the impact of x2 on y. But in the incorrect model, alpha 2 is not equal to beta 2, because alpha 2 hat, the mean of alpha 2 hat, is equal to beta 2 plus beta 3 times B23, 32, which is basically the correlation between x2 and x3, which is the correlation between x2 and x3. Now, given that correlation between x2 and x3 is non-zero in most cases, and beta 3 is also non-zero given that x3 has a significant impact on x2, the value of beta 2, the value of beta 2 is significantly different from alpha 2, and therefore we can say that in case of model misspecification, when we have omitted certain variable, the model is the estimates of the model are biased. When do we have biased? What do you mean by biasness? That means the coefficients are not correctly estimated. So in this case, what is happening? The model is generally getting overestimated, and overestimation generally happens if B23 is positive. If B23 is negative, given that beta 3 is positive, it will be underestimated. So given the correlation between x2 and x3, alpha 2 gives an overestimate or an underestimate of the true beta 2. So whenever your model is not including correct terms, all the relevant variables that must be included, first of all, you will find that the error term is not, the mean of error term is non-zero. And in such a case, the coefficients become biased. Now, moreover, not only are they biased, but they are also inefficient, because in a case of multiple regression model, if you remember, the variance of beta 2, which is the case of this equation, the variance is given by this formula, which includes the correlation between x2 and x3. R23 is the correlation between x2 and x3. But if you exclude x3, the variance is different. So the variance also is different. So what do we conclude? That if you exclude variables that are relevant to the model, you commit a model specification error of the type of omitted variable. Not only are the coefficients biased, but also they are inefficient. Okay? Coefficients are biased as well as inefficient. Moreover, coming to the relation of that with autocorrelation, now please understand, VI is the error term of the model which is misspecified. Please understand, VI includes UI, which is, even if we, so let's start from a point. If this is the correct model, UI is free from autocorrelation. If this is the first is the correct model, UI is free from autocorrelation. But the moment VI includes a variable which is included in it, we know that inflation, the current value of inflation, will be related to its past value, right? So the current value of inflation will be related to its past value. If x3 is, let's take inflation. So what will happen? The current value of VI will also be related to the past value of VI. So what do you observe? That VI now contains autocorrelation because of the fact that x3, which is included in the incorrectly specified model's error term, contains autocorrelation. There is some question. What is specified by 3.2 and 2.3 in VIF? So R23 is basically the correlation between x2 and x3, which are the two regressors in the model, in the correctly specified model. I believe yesterday in the session on multicollinearity, VIF was discussed, where VIF is calculated as 1/1 minus R23 square, where R23 is the correlation between x2 and x3. If this is if there are more variables x2, x3, x4 up till xn, R23 instead of R23 we have R square from the as the R square of the auxiliary regressions. I hope that's clear. B23, B32 and R23 are the same. B23 is the correlation coefficient. R23 is the correlation coefficient. R square to R23 square is the square of the correlation coefficient. So B32 and R23 are one and the same. Okay. So what do we observe? That even though UI does not have autocorrelation, but VI will have autocorrelation because of the presence of X3 in it, which is correlated with its past values. Okay. And therefore, one of the important tests of model specification is to test autocorrelation. So whenever you find there is autocorrelation in the data, it indicates that there are certain variables which are included in which are there as part of this error term, which is causing the error term to be autocorrelated. So whenever you find autocorrelation in the error term, you suspect model misspecification of the type of omitted variables. Now, many a times we don't know what variables to be included, right? We might have included all the variables what we know to be included on the right hand side, but still we find there is autocorrelation. So we don't know what variable to be included. There is some chat. DB is done only time series data, this applicable primary data. Durbin Watson, you see, yeah, we can do for primary data also, not only for time series. So if you are checking for spatial correlation also, Durbin Watson test can be done. So what I was telling is that suppose many a times we don't know what variables to be included. Now, in this case, suppose we think of a time series data. Okay. Now, YT is defined as, let's take this is a time series regression. I'm not able to access my, I told you this pen tab so that I could have written on the screen. Suppose if YT is a function of X2, X3, X2Y and X3T and X2T. But we don't know what variables to be correctly included in that. There might be other variables apart from X2 and X3 that we have to include. In this case, what we do is that we understand that since in the current period, YT is a function of X2T and X3T. So YT minus 1 will also be a function of X2T minus 1 and X3T minus 1. Do you understand? If YT is a function of X2T and X3T, YT minus 1 will also be a function of X2T and X3T. X2T minus 1 and X3T minus 1. That means whatever variables affect Y in the current period should also affect Y in the past period. Now, if we don't know what are these X2 and X3, if I simply regress Y on YT minus 1, what happens? I'm able to bring the entire effect of all the variables that would have affected Y in the past period in the form of YT minus 1. So YT minus 1, if YT is a sum total of all the variables that can cause Y to change. So suppose if the value of YT is 500, Let me give you a simple example. If the value of yt is 500, this value of 500 is due to the fact that there are 10 different variables, x variables, that have changed in that have caused y to take a value of 500 in the current period, isn't it? If y is consumption, or say let's take demand of a particular commodity. If the demand of a particular commodity is 500 units, that 500 units that I observe in the current period is due to the fact that price of that unit in the current period would be something, income of the individuals who will demand that particular commodity will be something in the current period. Different factors that can cause demand of that commodity to be something will cause y to assume a certain number or value which is 500, right? All those same values, all those same variables would have caused y to take some value in yt minus 1 previous period. Therefore, yt minus 1 is a realization of all the factors that can cause y to change or take a certain value in the previous period. So even if I don't know what can cause y to take a certain value in the current period, if I run a regression of y on yt minus 1, doesn't it capture the impact of all the factors that can cause y to change? So that is the basic idea behind when we were talking about adding lags of dependent variable as regressor. So if omission of relevant variable is causing autocorrelation, by regressing y on its lag, I am basically trying to capture the impact of all the variables that we have not included in the model, but whose impact can be captured by the previous value of y by bringing in my dependent, by bringing yt minus 1 as a regressor. Further, if we add unnecessary variables, so if the model requires only x2, but if I bring x3, now in this case, there is no problem of biasness. Please understand, if there is omitted variable, there is problem of biasness as well as inefficiency. But if there is extra variable, there is no problem of biasness. It's only a problem of efficiency. Okay. So in this case, since UI, if this is the correct model, UI has no autocorrelation. If I have included extra variable, VI, what will happen? Simply alpha 3 will be insignificant, right? If x3 is an additional variable which is not required, but I have just simply added here, what will happen? Alpha 3 will become insignificant, but it will not cause any differences to VI. Unlike here, where by removing the variable, I was loading VI with an additional term, causing it to show autocorrelation. But here VI will not show any autocorrelation. Simply alpha 3 will show that it is insignificant, and there will be a problem of inefficiency in the model. Now, another test that we have for testing this model specification is Ramsey's reset test, which basically is based on an F test that I had planned to show entirely in R. So I have just 5 minutes left. So can the organizers tell me how should we proceed? Can we take, how much time can I take more to demonstrate few things in R now?
So you can
Just-
take 5 minutes.
Okay, just we have 5 minutes. Okay. So what I will do, I hope the entire session is getting recorded, right?
So yes, sir.
So I will show the demonstration in R Studio, and how do we load a data set, and then I'll show how to check for autocorrelation, autocorrelation and all. Yes, here. And participants can just have a look at the screen right now, and they can practice after the session. And tomorrow I will try to keep theory as little as possible, and we'll start with loading the data and working with it directly when we start the time series part. Okay. So very quickly, what I'm going to do is that I will go ahead and load the data, load a particular data set in R. So for that, what I will do is here, I have an option in my environment, import data set. So there are various options of importing data sets. I'm using one of the methods, import data set. I have an Excel file. Now Excel has become a default method in R, so there is no problem. Earlier versions of R, Excel was not there. We had to use a separate method. From Excel, let me just check what data set I have. This is Excel. Okay, this is a CSV file. Fine, no problem. So this is an Excel comma separated value file. This is what I will be loading. This is from Damodar Gujarati book itself, one of the example data sets from chapter 6, if you remember, child mortality as a function of female literacy rate, per capita GNP, and total fertility rate. Now getting back to R, I will import this data set. I'm unable to see my screen. I'll use the first option, from text. Okay, it gives me an option. Please select where the file is located. I'll use this method like we have opening the data set. I have in a folder called JK, and I will select this. So what I'm doing, I have selected import data set from text file. I have selected this particular file that I want to and click on open. Now, what do you see? The data looks something like this. The name of the file is multiple, and it will look something like CM, FLR, PGNP, TFR. This is the data set that we have. And simply what I will do is that I putting, and I'll click on import. Okay. So now what I get, once I clicked on import, I have got 64 observations on 4 variables. Now, once I have this data set, you will see the moment you load any particular data, you have got something called in the environment, it will show the name of the data set. If I click here, it will show me all the variables that are there in the file. First of all, what we have to do is that we have to load this like we were loading libraries. In the same way, we will load this particular data set in R. We will use the function called attach. ATT, come down, attach. You see multiple, automatically it comes, control enter. So I have been able to attach this file. I will send this data set today, and you can also work by looking at the recording. Now, once I have attached, I want to run a regression of child mortality on the remaining 3 variables, and I will show you how to run a simple regression in R. So for running a regression, first I will create a particular object or some sort of a memory bank where I will store the results. So I will call R1, which will store the results of the regression, R1. And this is what I call as the assignment operator in R, which is this less than symbol and a dash. It looks like a arrow key. Okay. So there are 2 parts of it. One is press shift and less than symbol, which is next to M along with the comma. And there is the dash, which is next to the 0 key on the top. Use the function called LM for linear model, open bracket. Now you see that these names are in capital letters, CM. So child mortality, give a space. And with shift, I'm using this, I'm pressing shift, and above the tab key, you will see a wavy, curvy sort of line. We called it as a tilde, TILDE. So I'll put a tilde. So tilde basically is used for defining formula in R. The CM will be regressed on FLR. Let's take only on one variable, FLR. Now, if I run this regression, control enter, what happens? R1 is also created, and it has stored the values of the regression. And how do I see the result of regression? Summary is another function. R1, where R1 holds my regression results. Control enter. Now, what do you see? It gives you a result like you see in Excel, Gretel, or any other software, where you have child mortality as a function of female literacy rate. This is the coefficient, which is the intercept. This is the slope coefficient, standard error, t-value, probability value. You have R square, adjusted R square, okay? And the p-values, everything of the F statistic are coming here. But now we want to see if there is autocorrelation in this regression or not, in the residuals of this regression. So for that, what we want to do, we want to use the Durbin-Watson test. Now you remember, where is Durbin-Watson test? It is there in the library LM test. So first of all, even though we have loaded, but suppose if we had not loaded LM test. So what you can do is that you check if there is a tick next to LM test. By now, you can see this user library will have so many packages because you had installed AER. It also installed a lot of dependencies along with it. Forget about, since we have lack of time, I will just call library LM test. I have loaded LM test. And now I will call DW test R1. See, R1 stores my regression. So I'm just giving the regression output to DW test and running it. Now, what does it say? Please try to understand. Durbin-Watson test. Data is from R1. DW value, which is here, it does an H test. Remember, H test. It gives me a value which is positive, but the P value is insignificant. You see, if it was less than 0.05, it is significant, but it is greater than 0.05, it shows it is insignificant. So there is no autocorrelation that is shown here. Even though it is positive, it's not shown. Let me show you another example. Instead of FLR, let me run it on PGMP, just to show you a case of where we can have autocorrelation. No. One second. Now, what do you see here? What we have done, I have regressed child mortality on total fertility rate. And here, what do you see? The DW statistic is positive as well as it is significant. It is less than 0.05 p-value. So whenever it is less than 0.05, the alternate hypothesis is true autocorrelation is greater than 0. True autocorrelation is greater than 0 is what? So null hypothesis will be true autocorrelation is equal to 0. So equal to 0 is getting rejected. And what we go ahead with is true autocorrelation is greater than 0. Greater than 0 means it is positive. So there is positive autocorrelation in this model. Now, how to correct? Please understand that child mortality, when it is regressed on only total fertility rate, this is a case of underspecified model, because this is only one variable that we have regressed upon and not all the variables that must be used in the model. So what do? We can run another model, which is the correct model, where we estimate R2 LM child mortality as a function of FLR. Now, this is the line number 8, what you see was a case when you have y as a function of only 1x. But now in line number 15, I will run a regression of y as a function of multiple x variables. So here FLR, if I want to add another regressor plus, next is PGNP plus TFR. So whenever you put a plus in between, it gives you, we are adding regressors, and this tilde tells you this is the regressant, that means the y variable, and after the tilde all are the regressors. I'm running this regression. Summary R2, you can see.
Sir, there is a request. Please conclude the session, sir.
Yes, I'm just last line of code. And the Durbin-Watson test R2, which shows now there is no autocorrelation. So even when we had only TFR as one model, which was underspecified model in line number 8, there was autocorrelation. But in line number 15, once the model is properly specified, there is no autocorrelation. So I want to end the session here by showing how to test for autocorrelation in R and R Studio and how model specification can show. I'll look at higher order autocorrelations tomorrow when we work with time series data. So I'll stop the screen sharing.
Sir, there are a few questions in the chat box.
Okay, I'll take up those questions. Here's how to export the regression results as table. Okay, see, there is here we get the result as a text file only. We can export it as a text file. I'll show you the reporting the exporting part tomorrow once I'm exporting some more regression results. Regarding when and I will also show you how to export graphs and everything tomorrow. Tomorrow it will be almost no theory, more only 95% practical. Okay, thank you anyway. When DW value and the P value does not match, then how? See, DW will tell you if the given autocorrelation is positive, negative, or zero. In the sense, if it is zero, no autocorrelation. Irrespective of the DW value is positive or negative, if the P value shows insignificance, you don't have to go ahead and say that if it is positive or negative autocorrelation. You know the basic idea of statistical equality and difference, right? In the sense, even if I have a beta hat or any statistic having any numerical value which is different from zero, but if the P value, associated P value is insignificant, it clearly indicates that the statistical value of that statistic is as good as zero. It is statistically equal to zero, right? So even if you get a negative or positive value of DW, but if the P value is greater than 0.05 by conventional means, I'm not disregarding that 10% or accepting only 5%. By conventional means 5% level of significance, there is no autocorrelation.
Participant, you can directly ask question to the sir. We will share his email. Through email, you can communicate with the professor.
Thank you for your feedback. Any further questions? I'm here.
Dr. Hersch,
Yes, Bhagirath.
thank you so much for combining theory and praxis in a very blended, smooth, and a very proactive manner. I think Mr. Ravi can end the session and take up the proceedings further. And those who want to raise questions, we will be sharing sir's email with his permission, and you can shoot him and bombard him with lots of questions. It shouldn't be a problem. Thank you, sir.
Thank you so much, Dr. Bhagirath.
I would like to extend my heartfelt thanks to Dr. Hersch Sahay for delivering such an insightful session on autocorrelation and model misspecification using R. Your expertise and clear explanation have truly enhanced our understanding of this important topic. I would also like to express my gratitude to Dr. Firdaus Malik, Team Jammu and Kashmir Economic Association, and Jindal Center for the Global South organizing this wonderful workshop. Finally, I want to thank all the participants for your active involvement. Thank you.
Thank you so much, Mr. Ravi. Dr. Firdaus Malik, if you are live, you can end the session, or I can take. Yeah, please. Dr.
Thank you very much. Again, good evening, participants, for your patience. And on behalf of Jammu and Kashmir Economic Association, General Center for Global South, I would like to, personally extend my heartfelt greetings to our esteemed speaker, Dr. Hersch, for his insightful, and it was actually a more comprehensive session on autocorrelation. And tomorrow we are going to touch multicollinearity and the way you have used R. And it shows clearly, your expertise and clear explanation to such complex concepts. Really, it was extremely valuable to all of us. The practical session and it is demonstration and the hands-on approach, where undoubtedly enhanced our understanding. And undoubtedly enhanced our understanding is the way you have structured the topics and the practical session, taking us to the Excel and making the tough or the most difficult topics UI, UJ, and I have learned a lot, and there was much more understanding about these topics where beginners or the students who have passed their graduation or even PhD, the small doubts the way you have cleared were quite wonderful. So we all together, me and the participants, we are confident that the knowledge shared today will greatly benefit us in our future endeavors. So tomorrow we are also going to join. So once again, thank you for sharing your time. I appreciate your time, and that is very precious. And the expertise with us. We look forward for much more opportunities for the collaboration in future. And in my mind, which was making me to discuss more and more and think more and more how to utilize your expertise in future. I definitely want to announce with the participants that we are going to have a big workshop, and I will request Dr. Hersch to have a workshop wholly based on our software.
Definitely.
So thank you very much for your time.
Thank you so much, Dr. Firdaus sir, for your words of appreciation. And thank you all the organizers, Dr. Ravi and Dr. Bhagirath and everyone else and the meeting for your feedback. And we look forward to a good session tomorrow as well. And rest assured, I'll try today, since I wanted to clear certain basics. I took some time in the theoretical part, and we took a lot of time in getting used to R also a bit. Generally what we do is that I take a 15-hour workshop, which is spread over 5 days, just to get people introduced to R along with statistics and basic econometrics. So we can plan such sessions, and we can plan more sessions on our econometrics time series as we proceed forward in collaboration with JKEA and OPGen Global University and other universities in the future. Thank you so much, and let's meet tomorrow. Good night.